All right, let's talk about something we all want. Software that just works. You know, apps that don't crash, systems we can actually rely on. So how do the pros do it? Well, it all starts with one absolutely crucial first step, a process that bakes quality in from the very first line of code. Let's dive in.
I mean, seriously, this is the million-dollar question, right? From the apps on your phone to the massive systems that run, well, everything, we just want stuff to be reliable. So how do developers stop those super frustrating crashes and weird bugs from ever happening in the first place?
Well, it's pretty simple, really. You start with a map. Think about it. You'd never, ever try to build a skyscraper without a detailed blueprint, right? Would you? Of course not. And software is no different. To avoid total chaos, you need a plan, a map that builds quality checks in from the very beginning, not just tacked on at the end.
Okay, so in the world of software development, this map actually has a name. It's called the V model, and this is a classic industry-standard roadmap. It's a really brilliant way to visualize the entire life of a software project, from that first spark of an idea all the way to the finished product.
The real magic of the V model is its shape. See, you go down one side of the V, breaking a big idea into smaller and smaller, more manageable pieces of code. And then you come right back up the other side, testing and putting those pieces back together until you've verified the whole thing works. The key takeaway? For every single step you take building it, there's a matching step for testing.
And this right here shows that perfect relationship. It's like a mirror image. On the left side, the development phase, you're breaking things down, moving from big, abstract ideas into super detailed code. Then on the right, the testing phase, you're building it all back up, verifying each stage in reverse. So development goes down, testing comes up. It's elegant, right?
Okay, so for right now, let's zoom in on that right side of the V, the verification part. Because it's not just one big test everything button. No. It's actually a really structured process with 4 distinct levels. It's like going from a bird's eye view of the landscape all the way down to looking at it under a microscope.
So this verification journey happens in these 4 stages. We start at the very, very bottom with unit testing. That's where we ask, does this one tiny little piece work? Then we move up to integration testing. Do all these little pieces work together? After that, it's system testing. Does the whole thing work the way we designed it to? And finally, at the very top, we have user acceptance testing, which is basically asking, hey, did we actually build what the customer wanted? And you guessed it, that foundation, unit testing, is exactly what we're going to zero in on today. Because if you really want to understand how great, reliable software gets made, you have to start at the beginning, with the very first building block of quality control.
So naturally, if we're going to be talking about unit testing, the first, most obvious question we have to answer is, what in the world is a unit?
So what exactly is a unit?
Okay, think of it this way. If your software is a giant Lego castle, then a unit is just one single Lego brick. That's it. Formally, we'd say it's the smallest testable part of an application. The whole point is to pull this tiny piece out, put it on the workbench all by itself, and prove that it works perfectly before you even think about connecting it to anything else.
So what does that look like in the real world? Well, a unit could be a whole bunch of things. It could be a single function, something that just calculates a total. It might be a bigger module that handles, say, user logins. It could even be a whole individual program, or in some cases, it can be as small as a single critical line of code.
All right, so we get what a unit is. It's the smallest piece. But you might be wondering, why bother? Why go through all the trouble of testing these tiny little pieces first? I mean, why not just build the whole thing and test it at the end? Seems easier, right?
Well, let me put it this way. You would never, ever build a whole car, roll it off the assembly line, and then decide to check if the engine starts or if the brakes actually work. That would be insane. It would be a total disaster. You test each critical part, the engine, the brakes, the steering, to make absolutely sure they are flawless before you put them all together. And that right there is the entire philosophy of unit testing. So again, why is this the very first step?
It all comes down to one simple, powerful truth. Finding a crack in a single brick, that's cheap and easy to fix. You just swap it out. But finding that same crack after the entire wall is built, now you've got a huge, expensive problem. You might have to tear the whole thing down. It's the same with software. A bug you catch at the unit level might take a developer 5 minutes to fix. That exact same bug, if it's found weeks later during system testing, could take days or even weeks and cost a fortune to correct.
And look, this isn't just some abstract theory they teach you in school. This is a real-world, everyday practice for developers. And they've got a whole toolkit of specific techniques and really sophisticated software to make sure they get the job done right.
To be really thorough, developers don't just poke around randomly. They use very specific methods to inspect the code. They'll systematically check every single statement, every if this, then that decision, every branch, and every possible path the program could take. They're basically trying to make sure there are no dark corners where bugs can hide.
And to do all that, they use professional tools to automate the process. Pretty much every major programming language out there has its own set of powerful testing frameworks. You know, for Java developers, there's JUnit. For Python, there's PyUnit. C# has NUnit. The point is, this isn't some optional, nice-to-have thing. It's a core, non-negotiable part of the modern developer's workflow.
Okay, so let's bring this all home. When we talk about building that high-quality, dependable software we all want, we now know exactly where that journey starts.
It starts right here. Number 1, unit testing is step number 1, period. It is the absolute first line of defense against bugs, and it's the rock-solid bedrock upon which all other testing, and really, the entire application, is built.
So if there's one thing to remember, it's this. By verifying that every single tiny piece works perfectly by itself, unit testing lays the foundation for building reliable, stable software. It's what gives developers the confidence to build bigger and more complex systems. It's the secret sauce for software that you can actually trust.
But that leaves us with one final fascinating thought, doesn't it? If every single brick is perfect, does that guarantee the building itself will be strong? I mean, what about the mortar that holds all those perfect bricks together? Well, that, my friends, is a question for the next level of testing.